So yeah, all right. So in 2026, I am very happy to launch quantum computing seminar at Texas State University. So this is a very like the first time of like the launching this seminar, but I'd like to proceed this seminar around a decade as a, like a 1 year period for each. So today's like the purpose is to explain the style of this seminar. And there's a like a big assumption regarding this seminar. So first of all, this is informal so that you do not need to care about the evaluation, first of all. And I want to be very like the honest with all of you in a sense that when I just sit in the like the classroom as this either the audience or the participant, I kind of actually don't care whatever instructors are talking about. So I time to time just care about some of the like the topics, but rather than that, I just care as long as I can get a good grade. I really didn't really care. So I don't want to provide any lecture, and I don't want you to just sit as a audience for this seminar. So that let me try to explain what I have in my mind. So first of all, so this seminar is for quantum computing. And we'd like to cover some like the decent amount of the topics that you might like to get some like the expertise through this like the experience. And some of the like the participants, I am very happy to also provide some of the research opportunity so that you are also able to write some of the paper from the certain like the project, depending on your like the interest and also the understanding or those like the factors definitely like the matters. But at the same time, how do we want to like the successfully like the launch like seminar? So here is my very concrete suggestion. So in order to start today's like the conversation, I in fact made the following. So let me share my screen. You might laugh about it. So did you use Discord channel when you play the some game with your like the friend? So I created the Texas State Quantum Computing channel, and there are a bunch of the like the items that I'd like to address the discussion so that there are some text like the channels that some of the participants can post whatever they want, and also there's also a voice channel. So even though I am currently recording this like the very first orientation, in a sense that after I post this like the recorded video somewhere, so there should be further Texas State student who will definitely show their interest to see, oh, this is so fun, this could be so cool. So the style of the conversation in this seminar is the following. So first, I share the link of this Discord channel. So if you want to join this seminar, then please just join. And once we gather, so and because my wife gave a like the birth for the second like the kid last week, so my schedule this semester is very messy. So that's why I just make the schedule of this seminar at 8 p.m. on Friday. This is sort of for me exceptional, but I also try to make some of the seminar to be like the on campus so that we will also meet in person at some point this semester as well. But basically, this is a Zoom seminar. So once we gather, say 8 p.m. On Friday, then what we'll do is the following. So we will just have the seminar around the 1 to 2 hours. Then what I'd like to do together is at the end of the each seminar, I want to record what you discussed during this seminar. So once we gather, then you can either discuss with me, that's definitely okay with me, or you can just directly jump into say voice channel of the Discord channel. So that will be not recorded so that there is no like the pressure because the only recorded part is this Zoom session. And this Zoom session, what we do is so you just spend around the 1 or 2 hours and discuss with your like friends, and I will provide all like the relevant like the notes or relevant computations and the topics or you care. And depending on our like the conversation, so each week I will just generate those like the notes that you might care based on all those AI like techniques. We know we can rely on those like the techniques at this point very well. So each of the like the seminar, I will try to make the record of what you study and what you understood and what you feel you'd like to try to go further, that kind of conversation. And I will generate the note for each of the participants with the reference that I already created. So here is, I assume you already saw. So the primary like the reference of this like the seminar is this like the book that I like the post this like the book for launching this like the seminar. So please do not like the misunderstand what I'd like to propose. I will not try to just give you the lecture, and I will not suggest to give you the homework in a way that fine next week please read this chapter. No, I will not do that. Let's just try to make ourselves very comfortable with this seminar in a sense that without any preparation. So and at the like in the like the evening of the Friday, you might feel, "Oh, I'm so tired," and you just wanna like to express your like the all kinds of frustration, anxiety, and also the moment that you feel happy with it, so that you can just see there's just the like the space that you can just share what you wanna like the express. So there are several separate like the topics that I'd like to cover from this like the textbook. So it covers basically three topics. Number one, the mathematical like the or geometric structure of the quantum computing. And I wrote one paper regarding this topic with some engineer in Samsung last like the year, that geometric like the structure affects the improvement of the quantum algorithm. This is a one like the track. This book want to track. This is one side. The second side is so-called like the quantum error correcting. So this is simply called by QEC, quantum error correcting code. So this is the topic that I'd like to develop very like the actively this year for my own research. And the last topic is quantum cryptography. So I'd like to just this year of the seminar just split the specific topic in these like the three directions. Don't get me wrong. So for each of the topics, there are a bunch of the branches of the topics that you can study some of the quantum algorithm. You can study some like the classical like the hardware. You can also study some of the like the important like the development of the quantum error correcting like the techniques, including like the Willow of the like the Google, for example. So it really depends on like your interest. But in order to launch some of the deeper conversation, I want to establish the common background in the following way. So from the like the book that I post, so I assume at least we need to get the common mathematical background of the quantum computing if you don't like to disagree with it. So that the common background I'd like to establish is this part. So that we need to at least know how to proceed the computation of two by two matrix over the complex numbers. So at least you should get the sense of how to get used to it. And there is a way to interpret each of the quantum circuits with the properties via the linear algebra. So this kind of the mathematical like the literacy should be better. And it might take like the for some of the like the participants just a few like the weeks. Some of the participants it might take few months. It doesn't matter. So once you just come to the seminar, then I'd like to split the topics, as I said, just into three like the different like the directions, either geometry or the quantum computing, quantum error correcting, or the like the quantum cryptography. But in order to start those like the specific like the topics, I first wanna establish the common like the mathematical background regarding quantum computing. This should be helpful. So in order to do it, what I will do is after the conversation with each of you, so there should be your own like the pace of understanding regarding the mathematical like the literacy regarding the quantum computing. So that once you just make this like the background through this like this seminar, then some of you might just start some of the project under my supervision, or some of you just want to dig some like the topics as you want to study further and further, and you can just give the presentation if you wish, and so on. So that's my basic idea. Then for like the one or two like the hours of the each like the seminar, if some of the week if you're super busy, then you can definitely skip. It doesn't matter. But some of the week, if you want to study further, but I'd like to just maximize the duration for just 2 hours because I also have other like the commitment. So the maximum like, duration should be 2 hours per like the week. So then once we get there, then you can directly jump into the like the certain like the Discord like the voice channel. Then you can initiate the conversation with some of your friends, or you can definitely make the conversation with me. But the Zoom session will be recorded in a sense that so other outside of the participant, like potential participant from the Texas State University want to join this like the seminar in a way that whenever they want to join, then they will also look at the common like the mathematical background of the quantum computing first, and then they also can study their own like the own topics. And once you already like establish those like the common background, then you can definitely like, teach them. You can lead the conversation, discussion for them, or those kind of things. But I will not just make myself as a like the lecturer or the like the instructor. What I'd like to do is after having the conversation with each of you, I will try to generate the note for each of you individually so that some of the note that could be about the detailed computation, some of the notes should be some mathematical abstraction, some of the notes should be just concerning the like the hardware and so on and so on. So one like the hardware for the project. So this is so-called the FPGA like a processor, which is very like the cheap one. For the quantum computing, like the real like the project, it takes more than like the 40 like the K for like the doing real like the computation. But this is really like the cheap. It just takes like the 10 like the 100 like a box. So it's very actually cheaper than the usual like the like the product that actually we really need for the quantum computing project. But anyhow, so if you really want to care the like the classical like the hardware side of the quantum computing, I'm very also happy to cover some engineering topics as well. In a way to we can discuss that together, and you can give some like the presentation, or you can just share your like the inspiration once you just study the topic through this like the seminar. It really depends on your like, interest and your like the mathematical background. So that's my basic idea. So is that kind of okay with you? So after all, so once you just initiate the conversation in the Discord channel, because it will not be recorded at all, but still I'd like to make the record in this like the Zoom session in a way that by end of the seminar each time, I want you to express your like the inspiration, what you discover, and what you want to point it out from your like the discovery, all those kind of things. So that's my basic idea. Is that okay with you? Of course, some like the at some point, if we feel we wanna like to dig some computation or some of topic all together, then I'm very happy to go over that also together in a way that all of us will be very happy about like the way to cover. But still I don't want to like to give you the like the lecture. So here's the first like the topic. And you need to know this definition and so on and so on. But at the same time, it does not mean that I will not force you. So still there are some common background that you need to know, and it might take time. So this like the harder should be not that easy, truth be told, but this is accessible in a way that each of the week we don't want to establish a common background, but I just want you to enjoy each week in your like the own pace. It doesn't matter, but whether or not you like go super fast or super slow, it really didn't like the affects to the others. So that's the all of this today's like the orientation. Of course, so after today's like the orientation, I'd like to make the conversation with each of you to just set up the like the goal for each, so that you can also initiate the conversation with your like the friends. So, but if you have any like comments, suggestions, or questions, please let us know.
I have a question. For the Discord, if I'm like telling someone about it and they want to join the seminar, could I just send them the link to the Discord?
That's a sensitive like the important like, question.
Would you rather we
You
just send them your
can.
email and you can talk to them?
Uh, Here is my just the permission for the st- either the undergraduate or the graduate student of the Texas State. Yeah, I'm very happy to accept any students so that you can just forward them. But outside of the community, it could be a little bit sensitive. I didn't mean that I will not allow any of the outside of Texas State to join this like the seminar. But in that case, I'd like to make the conversation with me. Does that make sense of you?
So, yes, if it's a student of Texas State.
Yep.
Okay. And if it's not a student in Texas State, just let them talk, get them to talk to you first.
Yep.
Okay, cool.
Yeah. Let me just ask each of your like, opinion in turn. So Logan, so do you have any other comments or questions?
Yeah, I don't have any questions right now. I still don't understand like which direction, like what I'm interested in terms of this. I mean, I understand that's something I'm gonna find out as we set up this background for it. But no, I mean, I'm happy to have more of a discussion-based seminar every day than just sitting and listening. So, yeah,
Yeah.
I'm excited.
Sounds good. Yeah, Marshall.
Yeah, I don't have any questions at the moment, but yeah.
All right. John. So you should like unmute your like the mic. We're not listening from you yet.
Yeah, I don't I don't know too much, but I read something about quantum computing um and I want to know like how they get because one thing I have read is they're saying that because quantum computing right now they're not very reliable, and I just want to understand more about it.
All right. So it sounds good. Then I'd like to like split today's conversation for the common mathematical literacy for quantum computing. So I'd like to just spend maybe around the 10 to like the 20 minutes for the conversation in Zoom together. Then I will just want you to just enter to the Discord like the voice channel. So you can just either like the quit from this like the Zoom session if you want, but you need to just come back. So I want you to just record like your like the comments. So in Zoom session that what you really like to figure it out from this like the seminar. So for like the 10 to like the 20 like the minutes, I'd like to let you know the definition of the one qubits, collection of the one qubit. So this is mathematical a little bit abstract. So today I don't want to cover the like the meaning or the implication, whatever, all those kind of the fancy like the things that we eventually want to encounter with it together, but just a mathematical like a part of the description. Is it okay with you? So you might, so if you just read the articles of the quantum computing, so you might saw this like the term somewhere. So the yeah, before I go for like the move forward. So Carter, do you have any like the comments or like the questions?
Nope, I don't think so. Yeah, I'll definitely
All
just have to
right,
read through all the intro stuff because yeah, I'm not really familiar at all yet. But
got it. So let me put the like the some comments that I wanna like the practice together for the mathematical term of the qubits. So when we consider the collection of one qubits, this is fancily called by the Bloch sphere, and in general, collection of n qubits. This would be called, this is now a little bit fancy. This is called by the complex projective space of dimension 2 to the n minus 1. I know this term is very, very fancy, but because we are now also learning mathematical like the side of the quantum computing, I want you to know the rigorous like the description of the qubits because the quantum computing concerns the qubits for sure. Is that okay with you? So today, I just want to let you know the definition of the Bloch sphere, which is quite cool. And so what I want to do is that giving you the lecture, I will ask you to describe this by yourself for each of you. And then I will let you just enter to the voice channel and you might just look at the following. So once you just click the description of the Bloch sphere, so I want you to just discuss this part. So here's like the rule. I want you to use, I highly recommend you to use any AI tools if you are familiar with using ChatGPT or like the Gemini, Cloud, any types of the AI tools for your like the computation, your intuition, further explanation, please go for it. Try to rely on those like the tools as much as you can, but you need to like to convince yourself that you are on the like the right page. So for in order to making such a like the confidence, then you can make the conversation with me if you want. So today, the first like the seminar I wanna just proceed is that I want you to know the definition of blogosphere with me, and then once you get it, then I want you to just read this like the section chapter with your like the friends, making the conversation, and if you wanna like the just like the finish today's like the seminar, then just rejoin to this like the Zoom session and just share your like the inspiration and opinion, and that's it. Does that make sense of you? So let me now start to describe the definition of the blogosphere. So which is a little bit non-trivial, truth be told. So first, you should know the definition of the projective space. So let's just search from the Wikipedia, and then I will get back to you. So I just search the definition of projective space from the Wikipedia page so that you can look at here. So let me check whether or not this is like the suitable. I don't think this is good definition. So let me just check the better one. So let me just even rely on the ChatGPT. Of course, I know the definition for sure, but I just wanna find a suitable like the explanation of the like the CP one. So let me just ask. So provide the mathematical definition of the blogosphere in terms of CP1. So this is the prompt I made, and I will share my screen. Yeah, let me share. So you can see my screen, right? So of course you can also search in your own way. So you might saw this type of the like the picture from the article of the quantum computing. So here's a fancy like the description. So I want you to just know this definition, just memorize because we will rely on this definition a lot from now on. So first, what we want to use is so-called the qubit like the state. Qubit state is nothing but the vector in C2. Is it okay with you? Vector in C2, but we always like the ignore the zero vector. So this like the phi is never zero vector in C2. Is that okay with you? So let's just consider the qubit state, which is a non-zero vector in C2. Then what we consider is the following. So if you're a math major, you might see this type of a tilde notation. Can you guess what this tilde notation really meant? What is it in general from the math, like the major, like the perspective?
I know it's
Is
sometimes
related
used,
to?
or
Yep.
yeah, as used as an equivalence relation sometimes.
Exactly. So if you are a math major, then you can indeed regard this as a so-called equivalent relation. But if you are not math major, that's fine. You can just say, so we'd like to identify each like the non-zero vector is C2 with just a multiply by any non-zero complex number. This like the C, like this notation just means just a non-zero complex like the values. Is that okay with you? So that as long as we can multiply by any non-zero complex like the scalar, then we will identify those as a same element. That's the meaning. So I think this already just provide or in like the sufficient like the intuition. If you do not know the definition of the equivalence like the relation, that's fine. Is that okay with you? If you're not math major. So then what we do is the following. So this like the CP1. CP1 is called by the complex projective, like the space of dimension one or complex projective line, is the collection of the pure like the qubit states. What that means is that we will just collect all possible alpha comma beta. But here alpha comma beta just means we identify all possible elements that we can multiply by any non-zero like the complex like the value. Does that make sense of you? So that if we just collect all of them, then we call this like the collection CP1, or this is called by the Bloch sphere. So I know this doesn't make sense of you at all for the first place, but this is the rigorous like the description of the collection of the one qubit. So let me just repeat. First line, we consider non-zero vector in situ. Is that okay with you up to here? Second line, we identify all like the non-zero vectors if one can obtain from one to there by multiplying non-zero complex value. This is the second line. And if you know the mathematical description of the equivalent relation, this is exactly the way to provide the relation that becomes the equivalent relation if you prefer for that. But doesn't that really matter? So that we identify all those like the such a like the elements, and if we just collect or single like the pieces of such an element, then this like the element becomes so-called the pure like the qubit, and such a like collection is called the Bloch sphere in quantum computing term, and this is we call the complex projective space of dimension one or complex projective line. This is the only definition today I'd like to cover. Of course, there are so many fancy things really happens, such as like the Hopf vibration structure, and also many interesting thing really happens. But today I just want you to see the definition of what is the collection of the qubit. Collection of the one qubit is just nothing but CPU. That is the collection of the elements that each element is defined as such a like the collection. So any like the questions or comments regarding for that? So what I will ask you is I want you to describe this by yourself here so that you can practice. Any questions?
Can you elaborate a bit more on pure qubit states?
That's like the good point. So the qubit states like the consist of the pure state with the like the mixed state. So we will eventually also look at the mixed state together. So those like the state will be is already provided in the like the review of the linear algebra. So there's a linear algebraic description of the pure state and the mixed state. So let's just discuss that once you just review those all by ourselves. Is that okay with you? So for a moment, I just want to look at the like the collection of the pure state, and that becomes CP1. Whatever definition of the pure or the mixed state is for a moment. Is that okay with you?
Okay.
Yeah. Anyone else? It looks a little bit fancy, but yeah, after this is all we need. So let me just ask, so each of you to just describe this in your own way, just in the slow way, and then let's just jump into the just reviewing section three, chapter three, to just together. So by just entering the like the Discord channel. So Liu, can you describe this like the definition in your own way?
Let's see. Qubit state is a vector. Non Oof.
Yep. I like that
Uh,
like response.
the second part, a goal phase. I mean, that makes sense. It's essentially set of all vectors that are what's the word? I'm forgetting the word, but you're multiplying it by some multiple of some constant of each other. There's an actual word for that that has a proper definition that I'm drawing a blank on. Uh, let's see. The qubit states I'm still a little iffy on, at least the math part. The with the p in the complex plane.
So let's do like this. So let's just do really as a like the machine of describing the mathematical like the sentences. So the first line, so consider the non-zero like the vector in situ. Second, so we will identify all vectors if we multiply by non-zero like the complex like a value, say lambda. Then we identify all of them. So if you're an engineering major, this is very like the enough. But if you're like a math major, then you can say, let's just provide the equivalent relation by multiplying by non-zero like the lambda. Then the the collection of the equivalent classes is defined as a CP1, which is a collection of the one qubit that we call by the block sphere. So I want you to just split line by line in the rigorous way. So first line, consider the non-zero vector in C2. Line 2, so we will either provide a equivalent relation, or we can say we identify each vector if we can multiply by non-zero lambda. Then, so once we identify such like the our elements, then collection of such like the identified element is called by this either CP1 and called by the block sphere. So three lines. Is it okay with you? I just want you to just memorize. But before thinking about the what is the meaning of this like the abstraction or whatever, this is very like the rich like the structure. So, but I just want you to just know the description of one qubit for a moment.
Okay.
Yeah, Liu, can you just repeat the description as just a machine?
Oh dear God. First part is like qubit state is vector as in like I guess in a more applied sense, it's essentially the position of the qubit. The next part is a collection of all the qubits that are uh, uh, multiples of a non-zero lambda of each other, and a collection of all those creates a CP1, uh, or the pure qubit state.
All right. Logan, can you describe the definition of the CP1?
Yeah. Um, I'll just start from the top in the same way. So a qubit state is a non-zero vector in C2. So if it's non-zero, we don't include C2 in our domain. Um, and then these physical states are all like two vectors. If they're collinear, they're related. Um, and so then if you were to collect them all, essentially CP1 is like a collection of lines in C2 because every vector on a line is related.
Great. Marshall, can you describe the definition of the CP1 mathematically?
From what I understand, so it's just like a geometric kind of point of view of a complex plane um, with in vector space. I guess the space itself is it can be a different type of space too. It doesn't have to be a specific vector space. Um, I'm not really sure exactly how they all relate to each other, but
Mhm.
yeah, that's where I'm at right now.
Yeah, so that's completely fine in a sense that this is the like the object we eventually encounter very frequently. So I just wanna just make the very like the first impression, but in a mathematical like the way. So that's what I need. But we will just try to digest this like the description one by one. So it will take time, but that's definitely like the
Okay.
vision. All right, John, can you describe the definition of the CP1?
Yeah, yeah. So okay, so a qubit state, as I understand it, is represented by a point on the surface of the sphere. So that is um, make up of a vector, a non-zero vector. Um, and so if we have all the non-zero vector add up, they will uh, um, um, become a collection of here qubit state.
All right. So yeah, Carter, can you also repeat the definition of CP1 in your own way?
Yeah, it's been a while since I've done linear algebra, but I can try from that perspective. So, from my understanding, basically you have non-zero vector in C2, and you basically take the span of that vector, but then you take the collection of all the possible spans of each qubit state, and that is CP1, from my understanding.
Yeah, cool. Yeah, very good. So yeah, that's today I just wanna cover for the very first like the orientation. Then now let's move on to the Discord like the channel. So I assume you can check the link from the chat, like the screen. Can you find like the link of the Discord channel? So let me just re-copy and paste. So you can directly jump into the voice like the channel. You can even like the exit from the Zoom session if you want, but you need to come back to just share your like the inspiration that what you learn. So I'll also join the voice channel as well. That because we are now learning like the math setup. So let's just jump into the like the voice channel here. So this will not be recorded, by the way, so that you can just discuss whatever you want. You don't need to get shy of it. So I want you to just review chapter 3 together, which is crash course on linear algebra. That's what we really need. And in this like the chapter, so as Liu already pointed out, there is a description, definition of the pure state. So if it satisfies this condition, this is called the pure state. Otherwise, this is so-called a mixed state. There's a description for that, but doesn't mean that you need to read the entire like the ingredients of the chapter like the 3. Just use this as ingredients to like the trigger the discussion with your friends. You can introduce yourself further and try to be friendly with the like the fellows here, and let's go for it. Is that okay with you? And of course, I will just hold this like Zoom session. So if you want to make any like conversation with me, you can just rejoin this like a Zoom and we can just make the conversation as well. Even I will just join the voice channel as well. Is that okay with you? So that now let us just turn up the camera for a moment. Yeah, John, can you find? Yeah, very good.
Yeah, I'm trying to turn it off. So do you want me to turn it off, Professor?
It's up to you.
Okay. Yeah, I'm trying to get it. So do I get out or?
You can just if you want, you can just quit from the Zoom session if you want, but also all of the participants just come back and just share your opinion. Yeah, pretty good. So the definition of the like the so yeah, so by the way, so let me just finish this conversation first, and then let me talk with the new participant in like the Zoom session. So the first condition, so we start from the vector, right? In the description of definition of 3.3, we start from like the providing the unit vector. Is that okay with you? Unit vector. And then we created the matrix. We created the matrix. So the first condition is called the so-called the Hermitian matrix. Say the dagger of the matrix equal to the given like the matrix. This is called the Hermitian matrix. Is that okay with you? If you just search
Yes.
the condition of the
I
Hermitian matrix.
Do you think you could mute yourself in the Discord?
Ah, sorry.
Thank you.
Is it better now?
Yes, that's
Oh,
much better.
okay. So
But
mhm.
yes, I do understand. Wait, no, could you repeat that last part one more
Yeah,
time?
so there are two conditions of the created like the matrix. So let me share the screen. So the first condition, this means the matrix becomes the Hermitian matrix.
Yes. Like, well,
And
that is the property of a Hermitian. Like,
yeah,
that's the
this is the
definition, right?
property.
Okay.
So the reason, so I assume you are not like the comfortable with why we are carrying these types of the properties, right?
Yeah. But also, I don't understand. Like, I mean, I trust that it's true, but I don't understand why the the product of a vector of itself in that way, like the outer product, gains that property. Like, why this
Mm-hmm.
has that property.
Sure,
Also,
sure.
yeah.
Sure. Yeah. So let me first like to talk about the like the motivation to just want to keep such a like a properties first, and let's also talk about the justification. So how it
Okay.
works. So
Perfect.
the reason to make the matrix to be the Hermitian matrix is so the most powerful theorem of the linear algebra is the spectral theorem. And according to the spectral theorem, that's about the whether or not we are able to mm, convert the given square matrix to be the diagonal matrix. That's the purpose of the spectral theorem. So in order to do it for the over like the real, the matrix should be the symmetric matrix, and over the complex like the numbers, the matrix should be given as a Hermitian matrix. That's the reason. So that the reason to put this condition is this matrix now becomes diagonalizable and all eigenvalues are real. And the eigenvalues are what from the quantum mechanics we can really measure and we can really see. So we require this condition to just make all eigenvalues to be real values. This is the key reason to just take as a quantum mechanical axiom. And the second part, so this is called the projection property, meaning that if we just take the matrix one step further, it will not change anything. So that if you just kind of visualize the situation that if we multiply by the given matrix, then we kind of just project down to the certain like the subspace. And once we just take the like the subspace, then it will not change anything. So this is a projection property. So all those like the properties are trying to just find the like the subspace or the direction that we want to like, take the projection, and then we can just deal with our eigenvalues to be the real, so that we are definitely be able to handle it. That's the like the sort of the motivation side why this really works. So let's talk about the just the justification side. So first let us look at this part. So is that okay with you to justify this way? So that if you, so we start from here. It's okay with you? Start from
Yeah,
here.
so I actually was just working on the Hermitian part. I hadn't even read the next part, the it how do you pronounce that? Why would you say that?
So,
Idempotence.
yeah, so idempotence means that
Idempotence.
if you take the square, it will be the same. That's the like the term of the idempotence.
I managed to justify for myself just right now
Sure.
the Hermitian part. So yeah, just going through this second half would be nice.
Yeah, so you are talking about the just asking this part, right?
Yes, that'd be great.
Yeah, so we have a matrix defined by using this outer like the product.
Hmm.
So multiplying, taking square, so taking square, right? Just we copy and paste the same form from here to here, right? It's a really tricky. Then what we know is this is actually nothing but the taking the inner products of same vectors, right?
Okay. Yeah, and if magnitude
So
is one.
yeah,
That's right.
it's a
Okay.
very tricky.
Okay.
And justification of this part is kind of the very similar. If you just take that's just a dagger, then you just apply
Mhm.
the dagger here, and you can easily say that just recovers the same thing.
Okay. Yeah. Okay. Yeah. I need to get more comfortable working with
Sure.
this bracket
Yeah, this will
formation.
be used
I
very
like expanded
repeatedly.
out with like phi one, phi. It's like psi one, psi two to psi n.
Yeah.
Okay. Yeah. That makes a lot more sense in that form. Thank you.
So so there is a new participant. So is it correct? So Khan, are you new here?
Yeah, I'm new here. I was in pretty late, so we'll catch up with you later.
Yeah, sure. So, if you don't mind, can you just turn on the camera so that let me explain the structure of this seminar? So still you are not late at all.
Just one second.
And let's just hang on. Let me
Oh,
also
can you
talk
see
to
me?
yeah, I can see it. Just give me just a yeah, Khan, your turn. So can you return your camera so that I can try to explain? Yeah. So welcome to the seminar. So because my wife gave a birth last like the week, so I was like thinking to make this seminar to in person on campus, but literally I am not able to do it. So at least for this like spring semester, I will just hold this seminar on each Friday from 8 to basically 10 p.m. But this seminar is not the lecture style. So let me try to explain the structure of like the seminar so that each of the participants feel like comfortable with like the how to like the catch up the interest in like the topics each of the participants like the way. So
Okay.
first like the reference. So the reference so I already shared the reference. So yeah, this is the reference that I wanna just the study each like the pieces depending on each of the participants like the interest, but it doesn't mean that I will just go over each like topics in the lecture style because this like the book splits the three different tracks in the separate like the way. So track one, geometry or the mathematical like the structure of the quantum computing. This is one side. And the second like the side is a quantum error correcting. This is the second side. And the third side is a quantum cryptography. So I will not just force each of the participants to study all those like the topics. There's some topics that one might not really care. So, but in order to study any of these like the three topics from this like the book that I like to post on the archive like the website. So still we need to have the common mathematical literacy for the quantum computing. That should be still required for whatever like the directions that people care. So in order to catch up the mathematical literacy, these are what I'd like to study for all participants of this like the seminar. And by the way, I'd like to hold this like the seminar around like the decade for Texas State University. So what I imagine is once any of the Texas State like the students just either undergraduate, graduate just join this seminar, then I first let them review. I didn't mean that they need to study when they have a time. So they can just join this seminar and they can study this together. So I will also explain how to like the studies to like the topics together. So, but these are what I will like to let students to review to understand the further like the topics that they might care. Is that okay with you? So those are just
Yeah.
a review of linear algebra first of all, and the basic like the ingredients to understand the quantum circuits via the linear algebra. But because I am working on geometry a lot, so this like the place with the geometry like the favor. But this is still very like the useful as the, for example, collection of the one qubit. So I've been making this record. So if you just look at the this record at all, so the collection of one qubit becomes the so-called Bloch sphere. So that the geometric like the interpretation play a significant role in quantum computing. So I will explain all those properties like reviewing the materials. Once one get that, then there are like the more like the specific topics that the participants do not need to study in this like the order from this like the table, but depending on that their interest, they can just study for each of the single like the pieces depending on like their like the taste. So, but the way to study of these topics are in the following way. So this is not the lecture style seminar. So what I will share for this like the seminar is let me just recopy and paste the link. So this is the link of the Discord channel. Discord channel. So once you access, so you might have an experience for using Discord with your friends to having some like they're playing the game together, that kind of things. So this is the Discord like the channel of the Texas State Quantum Company that I created this today. Then it consists of two channels. One is a text like the channel, the other is a voice channels. And I already split some of the like the topics that one can just try to make the further conversation during the week. So for example, so the students are gathering here. So making the conversation regarding section or chapter 3 of the main like the reference. Is that okay with you? So 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 once we just gather in this like a Zoom session, this Zoom session will be recorded. But I don't want the students to get like the forced or like to feel like the overwhelmed to just express that they might feel I might be ignorant of that some topic that I still do not know. I need to still catch up. So this like a Zoom session is just to determine the direction of the conversation each time. Then once we get the direction, then we will enter to the like the Discord voice channel with the participants, and that will not be recorded. Then one can just initiate the further discussion and just making the conversation there. And then before we end the seminar, then we regather to the Zoom session, and then we will just share what we learned, so and share our inspiration, and also we can post something on Discord channel if any of us want to do it. So that's the like the style of this like the seminar, so that the pace of the like the understanding should be very different for each of the participants for sure, and also depending on their like the background and their own interest. So one do not need to like the catch up everything one by one. So it really just matters that if so say if you just join today, then just read section 3 in your own way. If you just dig through the like, definition, just one single like the piece of the definition, that's completely fine. Then next time you can also start from your like the pace. Then you can just study, but of course you can discuss this like the topic together for sure, also with me if you want. And then you can just enjoy in this way that without any preparation and without any like the pressure of the evaluation, for example, then you can just study in your own pace. But once you just catch up this like the common like the chapters that we definitely should note for studying quantum computing, then so it really depends on each of us like the motivation and effort and the like the interest to study the further topics. And some of the either undergraduate, graduate Texas State University, I'd like to also design some of the common project together depending on their like the effort. Does that make sense, Abhi? So
Yeah, got it.
yeah, so that's the basic idea. So if some participants feel very busy and if you wanted to skip, that's completely fine. But in this sense, so one can just study the quantum computing in the consistent way. So that's the basic like the structure. So if you have any questions or comments, let me know.
Yeah,
Does that make sense of you or so is
yeah,
there?
that's I got it clear.
All right. Let me let like the participant from Discord to rejoin here and we can just just record their like the understanding, and we can finish the seminar here. Just hang on. All right, guys. So if you guys don't mind, please turn on the camera and let's just try to present in turn that what you like that discovered today, what you learn and what you want to share, what you feel uncomfortable with, all those kind of things. And you can also tell your like own like the plan to like the just dig through the common like the part of the like the mathematical like the pieces and so on. So let me ask the order from like the Logan and like the Liu, and then I will ask the other participants next. Logan, can you go ahead?
Yeah, so I just worked through the first few definitions and the examples, and I made sure to like fill in the gaps of just the in-between steps to make sure I knew actually what was happening in the linear algebra. So I worked through up to definition 3.3, and then 3.4, I was just moving on to the standard inner product. But um, 3.2 and 3.4 introduced the outer product. And so I worked through the linear algebra, just getting comfortable with this new notation. And whenever it stated something like, oh, it has this property, then I tried to show that on my own before, like I couldn't earlier. Yeah. But other than that, I mean, I don't think I got very far. I'm gonna keep going at it. Sorry, you're muted.
Yeah, sorry. Yeah, cool. Yeah, thanks for the explanation. So, Liu, can you just explain what you have done?
Did you say Lou with an L or Rue with an R?
So I will, yeah, thanks for the like the correction. So should I need to call you as like a Liu or Lu? I mean you. So am I pronounce your name correctly? So yeah, sorry. So for the pronunciation R and U L, so I always feel I need to make more like the clear like
You
the
know what? Call me
pronunciation.
Taylor. Call me by my last name. Call me by my last name. Let's just.
All
I'll
right,
just
yeah,
be Marshall.
Taylor. Yeah,
Yeah.
Taylor. Can you just
Okay,
explain what
okay.
Yeah, thanks.
Um, let's see. Mostly it was a review of linear algebra that I was rusty on or had forgotten. Anytime I saw something that I was unfamiliar with, ask of course ask questions, but I'd also try to work through some of the algebra to make sure that I like actually understood what's going on. Take notes of anything that felt even a little bit unfamiliar. I got up to 3.12 before we ended.
Yeah,
Uh,
awesome.
yeah, that's
Right. So yeah, Marshall. So can you just share what you did?
So I kind of went down ChatGPT lane, and I wanted to get like a more visual understanding of this. Um, so I kind of got into Hermitians and why they're observables, measurements and stuff like that, what the complex conjugate is and why that is related to global phase. Basically the roadmap of like how it starts off from a vector and ends up in a like vector space. So that had a really good well like readjustment from how I think about this linear algebra stuff. Yeah.
Yeah, awesome. Carter, can you just share what you did?
Yeah, so I'm pretty much just like skimming down and reading through and trying to adjust the new notation and then making sure I understand like the core idea. Most of the ideas I get pretty easily because they're just new notation on old stuff. So once you understand the notation, it's fine. Um, I just definitely have to review a lot of linear algebra stuff because a lot of it I've forgotten because it's been so many years now. But yeah.
Yeah, all right. So before we finish today's like the very first like the seminar, so I want to get the very honest feedback regarding the style of this seminar. So my purpose of like the making the seminar style in this way is to just reduce or remove any like the pressure or like the getting overwhelmed regarding like the learning new topics, especially this there's no evaluation, but there's must be the motivation to learn something like the deeper. So in order to do it, we need to be a little bit like the patient and it takes time. So in order to do it, I think this is my current like the best like the way to proceed this like the informal seminar. So please tell your like the opinion how you really feel, and if some like the pieces you feel against it, I'd like to really like the reflect your like the opinions as well. And if you feel this is good, then also this good to like to share. So if any of you want to share these types of the like feedback or thoughts, please let me know.
No, I like this format. I just think it's going to take a little while for us to sort of warm up into it. And I also like, I know your schedule is busy, but if we can manage to meet in person, I think it'd be quite engaging to do that as well. I mean, we'd be actually be able to maybe show each other things.
Sure,
But
I'll
I think
definitely
we'll be
make
able
such
to,
a like the event. Yep.
once we get into the pace of it, I feel like it'll work much better.
Yeah, thanks for that feedback. Mhm. Anyone else?
I will say I do think it is a tad bit awkward for it to be virtual. That's just the nature of doing anything virtually. However, I do appreciate much more laid back. May not be the best way to put it, but I'm going to use that term. Nature of this. I like just being able to read through it and like read through whatever text we're going over and doing this thing. And it's like, hey, what am I looking at? Like, someone help me out with this. I do appreciate that.
Yeah, yeah, thanks for your comments. Yeah, anyone else? Yeah, Marshall or Carter, do you have any other like the ideas to share, or it's okay with you?
No, this works for me. Yeah.
Yeah, same. I guess
Mhm.
probably only applies to now, but maybe like glossary definitions, just quickly glancing over everything. We can all like try to interpret them each and just like go over as a summary real quick is what the goal of uh the meeting would be. But yeah, it kind of depends on all of us, I guess, what stage we're at.
All right. Yeah, yeah. So basically, it seems the participants, majority, you like it. So let me just set up what I want you to just do. So in Discord channel, so it seems we need to have some like the ice break like the moment. So after like this like the seminar, so of course you send me the email with your like the introduction, but I want you to know each other. So this is a good time to also get to know of the like the people that you should know. So please just post your like the introduction. So let me make the channel right now. Introduce yourself. And next time we can try to make more like the frequent like the conversation in a way that you might not feel really awkward in this like a virtual like a platform. And I also try to make the event that we can also meet in person on campus so that we can feel more like the friendly with each other. So this is a very like the first like the seminar, and I really do appreciate that you all get involved in this the conversation, even though this is not really like the familiar like the platform that we learn like the from like the lecture like the style. So let me stop the record.